All right, we're on day 5. Packet page 26 to 27 is your homework. We're going to look at segment and angle subtraction today as well as midpoint. So our warm-up, so we've got RS is 3x plus 1. ST is 2x minus 2. The whole thing RT is 59. So we're going to take small part plus small part is equal to the whole thing. Our geometry reasoning here, the justification, is our segment addition postulate. So if we combine our like terms, we get 5x minus 1 equals 59. We can add the 1 over to get 5x equals 60. And divide by 5 to get x is 12. Always reread the question. They wanted to know what x is, so we are done. All right, on the homework, we wanted to add DO and OG. Now, it did not specifically say in the directions that you had to justify your geometry steps. So if this was a test or a quiz, you wouldn't lose points if you didn't. So that's why I didn't put them there. But our reasoning would be our segment addition postulate. Go through and solve. You get x is 13, and that's all that they wanted. Similar idea here. Small part plus small part equals the whole thing. That's our segment addition postulate that allows us to do that. Get y by itself, you get y equals 7, but the difference here is they didn't want to just know y, they wanted to know what RS was. So take your expression for RS, sub the 7 back in, and we end up getting 60. Now as we're going through these, if you need to pause and look at the work longer, you can. So I'm just going to talk through it somewhat quickly, but if you need to copy down the work to make your corrections, just pause the video and you can do it right there. So here we knew that Kc was 31, so we could set up an equation for that. 2x plus 10 equals 31. We get x is 10.5. Then we want to find Kn. Well, Kn, we're doing the two small parts added together equal the whole thing. So this is Kn equals that, and that's using the segment addition postulate there. We fill in the 10.5, and we get that Kn is 74. Here we've got the angle addition postulate. Again, it didn't say you had to justify the geometry steps, but if on a quiz or a test it did, that's what you would have written for that first step. Go through and solve, and we get x is 31. Go back and reread the question. That's what they wanted you to do. We didn't have to sub back in. All right, so they told us what RT was here. So that was the whole thing, 2x plus 35. That's our segment addition postulate. That's allowing to add those together and set it equal to the whole thing. We've got a quadratic because we have a mixture of x squareds and x's. So get everything on one side, factor, solve. We get 6 and negative 5. We want to find what AT is. But remember, when you have quadratics, you just want to check out and see if things make sense. Usually a negative answer, if there is one that might not make sense. And notice if you put negative 5 into the RA, you would get negative 5 plus 5, meaning RA is 0. So then there would be no segment there, so it wouldn't exist. So that's why we reject the negative 5. So just the one from 6 we would want, and we end up getting the 36 for AT, which is what we are looking for. All right, so next page in your packets where we're going to start our notes for today. So we're going to do 22. So we'll start out, it's kind of the reverse of what we did before, and it's the segment subtraction postulate. So say we knew the whole thing and one of the parts, we could use that to find the other part. So say we knew the whole thing AC, and we also knew, say, BC. We could subtract those, and that would give us the other small part, AB. So a big plus a small leaves us with the other small. And then similar, and again, you can write that right on top of your gray box or next to it in your notes. Similar idea with the angles. We can take the big angle, ABD. Now another name we could have used for ABD is DBA. You could go in the reverse, but you could not just call it angle B because there's multiple angles going on there. Subtract the small angle CBD, and you're left with the other small angle ABC. So that would be the angle subtraction postulate. So down on the bottom, we're working with CAT again, and A is somewhere between C and T. CA is 14.8, and CT is 112.3. We want to find AT. Well, AT, the small part, is going to equal the big part minus the other small part. And our justification would be segment subtraction postulate. Okay, it seems like common sense. If you take a big part, take away one of the smaller parts, whatever remaining, the other small part is what you'll be left with. So if we actually punch that in to subtract it, you get 97.5. In the bottom one, MAT, so this angle here is 108. HAM, so the whole big thing here, is 162. And we don't know HAT, the measure of that. Well, the measure of angle HAT, now you might notice when I write angles, I'll sometimes put that little mark in there just to differentiate it from like a less than sign, so it doesn't look the same. But the measure of angle HAT should be the big one, so 162, minus the one small one, and that'll give us the other small one, HAT. And that is our angle subtraction postulate. So when we subtract those, we end up getting, oops, not 100, just 54 degrees. Okay, so we go to the next page, page 23. The other thing we're going to look at today is what's called the midpoint. So the midpoint is a point that divides a segment into two congruent segments. Notice it's dividing a segment and not a line, because a line goes on forever. There's no middle spot. You can't divide it evenly. So it has to be a segment. So a couple things. The marking that would show that in a picture is the little tick mark. So see how they each have one mark there? That tells us that AB is congruent or equal to BC. They could also do it with 2 marks or 3 marks. Basically anything that has the same number of marks would mean those things are congruent. Now, congruent might be a new word for you. So you could also say equal. Equal we usually say when we're talking about the actual measure. Congruent we say when we're talking about the physical segment itself. We will see congruency a lot this year. The congruent symbol is the equal with the squiggly sign above it over there. So we could use those interchangeably. The geometry reasoning that we'll write out when we use this, we will say midpoint. We'll draw a little arrow to mean implies, and then we'll write 2 congruent segments. So anytime we use our midpoint rule, that's what we'll write out, that the midpoint implies 2 congruent segments. Now, if a line or a ray passes through the midpoint, we say that it bisects the segment. So if we had the same picture of ABC, and we had a line like that going through, we would say that line bisects ABC. The line is slicing it in half. So to look at an example, R is the midpoint of AC. If AR is 12, find AC. So let's draw a picture. So we got AC, and we know R is in the middle. Because it's the midpoint, let's put our markings to show that they're equal. So we know this is AR. So AC should, oops, sorry, I meant to write that AR there is 12. So we have 12 plus, well, because midpoint implies two congruent segments, we know that one's 12 as well. So we would write for our geometry justification, midpoint, the arrow, which means implies, and then two congruent segments. Well, now this is pretty easy. AC just equals 24. Going down to the bottom, we now have C as the midpoint of AB. Now, I don't know if I've said this specifically yet this year, but anytime this year, if they're talking about something and there's not a picture, it's a good idea to draw the picture. It can help you visualize it. So because it's the midpoint, we'll go ahead and put our markings on. They tell us AC is 2x plus 1. They tell us CB is 3x minus 4. Well, because we had a midpoint, we know those should be equal. So we can do 2x plus 1 equals 3x minus 4. And we'll say our midpoint implies, which we show with an arrow, two congruent segments. Well, now we can just go through and solve. We'll subtract the 2x from both sides. That'll give us 1 equals x minus 4. We can add the 4 over, and we get 5 equals x. And we'll reread the question. Is x what they wanted? Nope, they wanted us to find CB and AB. So CB is 3 times 5 minus 4. Or in other words, 15 minus 4. So CB is 11. Well, AB, the whole thing should just be double that, because they're each the same. So 2 times 11, so that should equal 22. Moving to the top of page 24, we've got our picture over on the right there. When you see this picture, you want to recognize those markings, and that's telling us that CH and HK are the same length, meaning H must be a midpoint. So they give us expressions. CH is 6x minus 6. CK is 4x plus 8. And we want to find HK. Well, we know if CH is 6x minus 6, we know HK is 6x minus 6. And then we know that we can add the two small parts and make them equal to the big thing. So we're going to have 6x minus 6 plus 6x minus 6 equals 4x plus 8. Now you could have also said 2 times 6x minus 6 on the left side, and that would have been fine as well. Now our geometry justification, we actually have two justifications we used. We used that midpoint implies two congruent segments. That's what allowed us to say that HK was also 6x minus 6. And then we also used the segment addition postulate. And that allowed us to add the two small parts equal to the big part. So combining like terms on the left, we'll have 12x minus 12 equals 4x plus 8. So we're going to subtract the 4x over. That'll give us 8x minus 12 equals 8. We can add the 12 over. We get 8x equals 20. And then divide by 8. And notice 8 doesn't go in evenly. Okay, but everything's not always going to work out nice, but it's actually pretty nice. If you do 20 divided by 8, you're going to get 2.5. So that's not too bad. Well, let's see what they wanted. They wanted HK, which was just the little part there. So HK equals 6 times the 2.5 we just found minus 6. If you do 6 times 2.5, that's going to give us 15 minus 6. And 15 minus 6 will give us 9. Moving to the bottom of 24, we're given two angles there, and they tell us that XYZ is 98 degrees. Now, in reality, if the directions didn't tell us anything specific, we would probably use angle addition for this. We'd do the 20 plus 7x plus 4 equals the 98. But they want us to use angle subtraction in the question. So let's take our big one minus one of the small ones. Well, the easier one to subtract is going to be the 20. That equals 7x plus 4. If you decided to subtract the 7x plus 4, you'd have to make sure to put it in parentheses and distribute. Now, our geometry step that we have to tell is we use the angle subtraction postulate. We're going to get the same answer as if we had done it with angle addition as well. So this would just be 78 equals 7x plus 4. We'll subtract the 4, so we'll get 74 equals 7x. And if you divide by 7, it doesn't come out nice, note. And that's okay. If something does not come out nice and it doesn't tell you to round, just keep the answer as is. Okay, as you keep getting higher levels of math, okay, things are not going to come out nice all the time. Now, it's good if it's not coming out nice to just check your work, make sure you didn't make an error, but it's not always going to come out nice. All right, our last one for this video. A, B, and C are collinear points with B in between. AB is x plus 19. BC, we got 2x squared plus 2x plus 9. And then AC, the big thing, it's 3x squared plus 5x plus 4. Now notice, they tell us they want us to use segment subtraction postulate. The logical way to do this would be to use segment addition, add the two small parts to equal the big, but they want us to do segment subtraction. So let's start with the whole. So 3x squared plus 5x plus 4 minus. Subtract off whichever one's easier. Let's do the x plus 19. We've got to make sure to put it in parentheses so we subtract the whole thing. And then it equals our other small part. This is like having a negative 1 in front. So we've got to distribute the negative 1 through. So it gives us a negative x minus 19, and we'll just rewrite everything else. No like terms for x squareds on the left, but we do have like terms for the x's. And we do have like terms for the constants. Now I'm going to show you something that if you're okay with it, I'm fine you doing on tests. If it confuses you, you can do it one by one. But we need to move everything over to the left because it's a quadratic, and that's where our bigger x squared is. So we can subtract the 2x squared over, And I'm okay if you want all at once, also subtract the 2x over, and also subtract the 9 over. Because they're each going to match up with their individual parts, and this would give us x squared plus 2x minus 24 equals 0. Okay, if you don't like that, if it's too much, you can just do them each one at a time, but it saves us a couple steps by doing that. So we want to add to the 2 and multiply to the negative 24. So we need a positive and we need a negative. We need the positive to be bigger. And the one that would work would be plus 6 and minus 4. We'll go ahead and set each of those equal to 0. And in solving, we get x equals negative 6 and x equals 4. Now our negative 1, remember, just want to check out and make sure it's not going to give us a negative. Well, let's check each of our things. Negative 6 plus 19, that's a positive, that's okay. If we did it in the BC, negative 6 squared is 36 times 2 is 72. Negative 6 times 2 is negative 12 plus 9. Okay, that's going to give us a positive, that's okay. And if we look at the big one, negative 6 squared, again, is 36 times 3 is 108. Negative 6 times 5 is negative 30. And then plus 4, okay, that's going to give us a positive. So both of them will work out in this case. So we have two possible answers. And sometimes that will happen. All right, so upload your homework to Schoology tonight after you do it. Any questions you have, you can post them on the content discussion board.